GCSE PE. We are doing some skeletal system revision today. So this podcast, again, there's no pictures to see on this podcast. It's an audio podcast that you can listen to help you revise for a section test or an end of unit exam or a final exam. This is a paper 1 topic. It is anatomy and physiology topic. Paper 1 are physical factors affecting performance in sport, and said this is on the skeletal system. So we're just going to go through the main areas of the skeletal system that you could be asked questions on. Again, I can't cover every question you could be asked on this podcast, but it's just a different way of revising. Obviously, you'll have your books, you'll have revision guides, etc., but it's another way of revising the same information, really. So we'll start off with the skeleton names. Again, just remind you on this, you need to make sure that you have the correct terminology. We need GCSE names for the bones, not more common names that everybody else might use. So if we start at the top of the body in the cranium, which is you may have previously called the skull, we called the cranium. I will also say spellings are important. No one's going to try and spell things wrong, but obviously do try your best to get your spellings correct. So cranium is at the top, which protects the brain. Going down the body, we start at what you would have previously called your collarbone, which goes across the front at the top. That's now, you're calling that your clavicle. Your shoulder blade, which is obviously at the top of your back, behind your shoulder, if you like. We call your scapula. Going down the arm, we have the top of the arm, so between the elbow and the shoulder, we have the humerus. And then in the lower part of the arm, we have the ulna and the radius. Remember, radius is the one that goes to your thumb. So if you stick your thumb out, it makes an R with your thumb. And ulna, U for underneath, is the other bone in the lower arm. Then in the hands, we have carpals, metacarpals, and phalanges. Going back up a little bit, we have the ribs, which sit obviously in the upper part of the body, protecting your heart and your lungs. And the middle of your ribs, down the middle, like a plate at the front, is called your sternum. Going down, we have your vertebral column, which you may have previously called your spine, but we call it your vertebral column, your vertebrae. We then have your pelvis or pelvic girdle. And then going down into the legs, we have the femur, the longest bone in the body, which is from your hip to your knee. We have the patella at the knee, which is like your kneecap, the patella. And then we have the two bones of the lower leg between the foot and the knee, the tibia at the front, tibia, and fibula at the back. So tibia and fibula at the lower leg. And then into our feet, we have tarsals, metatarsals, and phalanges. All bones can be classified into different sections. And again, we looked at that very briefly. It's not a massive question that's come on the paper, but definitely worth knowing. We have long bones, short bones, flat bones, and irregular bones. So flat bones are normally for protection. Short bones are normally for strength and lots of movements because they've got lots of joints. Long bones are levers that help with movement. They also have blood cell production in there. And irregular bones have a very specific job, like the vertebral column, which is there to protect the spinal cord. So they have very particular jobs, the irregular bones. Just worth mentioning that. As I said, I've not seen lots of questions on the types of bones, but just worth mentioning. Okay, from there we move on to the 6 functions of the skeleton. Again, we've covered these in lesson. There are 6 functions. It's just really important you know the 6, and it is a matter of learning these 6 and be able to give a sporting example of when you may see those 6 come into play. So we'll start with protection of vital organs. So the cranium protects the brain, the ribs protect the heart and lungs, etc. So one job is to protect the vital organs. Examples of that: getting punched in boxing, the cranium would protect the brain. Getting tackled in rugby, the ribs would protect the heart and lungs. Nothing complex about that. They stop your body from getting injured. Second function is that of movement. So your skeleton helps you move. Without skeleton, you would not be able to move, really, in 2 ways. One, it has joints, which allow movement, and 2, it provides attachment for muscles. So movement is the second function of the skeleton. The third is support, in that your skeleton gives you shape and holds everything in place, including your vital organs. The vertebral column in particular holds your body upright. So you need that support to be able to get shapes, to move body shape, to be able to stand upright, etc. Examples can be anything where you're moving. So something like a handstand where you're taking your body weight through your hands, in that case, gives you shape. Again, you could even use example of a runner. So again, they need the body shape to be able to be in the correct position to run effectively. But there's lots of examples you can give of support, anything where you're holding your weight. Next function is that of posture. And again, posture is about the ability, similar links to support really, but it's about holding your body in the correct position that will help you avoid injury. So you've heard of people having good and bad posture. So you want good posture will put the least strain on the joints and the body and help you avoid injuries. Again, I think if a gymnast would be a good example of this. If the gymnast does not have the right posture, 1, they can't get the body into the correct position, the correct shape, and 2, they're more likely to pick up injuries. Posture being the fourth one. The last 2 are blood cell production. Blood cell production happens in the red bone marrow. And obviously red blood cell production, which is the key thing we're talking about here, is vital for you as a sports person. Red blood cells carry oxygen to the working muscles, so therefore more red blood cells helps you get more oxygen to the muscles, and therefore you don't get tired as easily. So it's absolutely vital. And again, an example of when this is important would be in any long distance event, long distance running, long distance swimming, where you need oxygen over a long period of time to keep you going. Long distance cycling would be another example, but always say why, because you need that red blood cells to deliver oxygen. Final function of the skeleton is storage of minerals, calcium, phosphorus, and others. And obviously you need calcium to keep the bones strong, which help you avoid injury. Example again, could be again lots of examples, but a footballer would need that storage of minerals. So if they get tackled, their bones are strong, so obviously can take the tackle and not get injured. And again, another one, a gymnast, again, taking all the weight through the body on landings when they're doing vaulting, etc., needs strong skeleton. And again, that storage of minerals would help that do that. So we've got 6 functions of the skeleton, just to recap: protection of vital organs, movement, support, posture, blood cell production, and storage of minerals. Okay, to just make sure you can give sporting examples of each one of those. And again, it's important you can say the most important one. So you'll find that a lot of sports or sporting actions may have more than one function of the skeleton happening at the same time. So a boxer would have protection, they'd also have movement, they'd also have posture and support, they'd also have storage of minerals and red blood cell production, all 6. But could you rank them in order of importance, higher order thinking skills? So again, for me, I'd probably go protection first because they're getting punched, then I'd go with movement. But you could possibly justify lots, but be able to rank them in terms of importance. Okay, after that, we've looked at the synovial joint and looking at the structures within a synovial joint. There's really only 5 you need to know. But a joint is where the definition is where 2 or more bones meet to create movement, because that's what joints do. I'm looking at synovial joints that are obviously freely movable and help you create movement. There are 5 structures you need to know. And again, you have the diagram in your book, so you can look at that again in revision guides, but I'll just very quickly explain the 5. First one is hyaline cartilage. Hyaline cartilage covers the end of the bone and acts as a shock absorber and helps you reduce friction. So if you imagine somebody jumping from a height and landing, and the bones coming together, that hyaline cartilage protects the ends of the bone and helps you avoid injury. So cartilage is on the end of the bones for prevention of friction. It's a shock absorber. Within the joint, there is a substance called synovial fluid. This is a substance that oils the joint, if you like, lubricates the joint, makes it work smoothly. And without synovial fluid, you'd have very stiff joints, painful joints. So synovial fluid lubricates the joint so it works effectively. On the outside of the synovial fluid, there is what's called the synovial membrane, and all the membrane is there is to keep the synovial fluid in the joint. So Otherwise, the synovial fluid would just leak out. You need a synovial membrane to keep that fluid in the joint doing what it wanted to. And finally, we have tendons. So the tendon's job is to join the muscles to the bones around the joint. So most famous one being the Achilles tendon going down your gastrocnemius to join your ankle, but we have tendons all over your body that join muscles to your bones. They're there for stability, to make everything, again, help you create movement, because when you flex the muscle, it pulls on the tendon, and then obviously the joint moves. And finally, we have ligaments, which is another connective tissue which joins bone to bone, again stabilizing the joint. So again, you've heard lots of ligament injuries in twisting and turning sports, football, etc. The ligament joins the bone to the bone. So again, it stabilizes that joint, keeps it in the right place. You could be asked in any of these type of questions as well on the skeleton about articulating bones. Articulating bones are simply bones that make up the joint. So if you take the knee joint, which is a hinge joint, for example, the articulating bones at the knee would be the femur, the patella, and the tibia. At the elbow, it would be the ulnar radius and humerus. At the shoulder, it would be the humerus and the scapula. And at the hip, it would be the pelvis and the femur. So the articulating bones are simply the bones that create that joint where movement would happen. Okay. Finally, we've been looking at movements that occur at joints. There are 6 movements that you need to know that happen at joints, and most importantly is that you're able to give a sporting example of each one. When you're giving a sporting example, please make sure you are specific about where in the movement that happens. A number of sporting actions have different movements happening at different times. So if I give you the example of a footballer kicking a football, as they pull the leg back at the start, you get flexion at the knee. As you strike the ball and then you follow through, you get extension. So you can't just say, as an example, kicking the ball. That's not good enough. You have to say when in that action. Is it in the preparation phase, taking the knee back, flexion, or is it in the extension phase, which is where you strike the ball and follow through, as I say, which is extension of the knee. So those 6 movements are extension, which is opening the joint, extending a limb, so that would be straightening the arm or straightening the leg. You can also get extension at the hip and the shoulder, which is where you pull your arm back straight behind you. You have flexion, which is flexing a limb. Again, you'd normally get this at all the joints, or the major joints, but flexion is closing a joint. So when you are bringing the arm back towards you, for instance, when you're a boxer, putting your guard up, or you're doing a bicep curl, you're closing the angle of the joint. I should have said before, in the extension examples would be throwing a jab in boxing. It would be as you take off doing a high jump and you extend your leg, it goes long and straight, or striking a football and the follow through where your leg is straight would be examples of extension. Flexion, the opposite, where you're bending the joint, but we say flexing the joint. Abduction is moving a limb away or from the center line of the body. So the center line of the body means draw a line straight through your head, down the middle, past your nose, down the middle of your body. That's the center line of your body. So moving a limb away from the center line of the body. So a sporting example would be, for instance, a goalkeeper making a save where they put their arm out to the side. They're moving the arm away from the center line of the body, abducting the arm. Therefore, this is abduction. There's lots of examples. A cricket wicketkeeper would do the same. You might get some abduction of the arm in a swimming stroke, maybe as you are rotating the arm to the side as well. So you get lots of examples of abduction. I always use the goalkeeper one. It's probably the easiest one. But the body goes, a limb goes away from the center of the body. You can also get abduction. Obviously, only at ball and socket joints. You cannot abduct a hinge joint. Okay. Rotation is turning or rotation of movement of a limb or a body part around a joint. So again, fairly obvious things like freestyle arms in swimming, where you rotate the arm around the shoulder joint. Cricket bowling again, so the bowler would rotate the arm as they're bowling to release the ball. Again, you cannot do rotation at a hinge joint. You can only do it at a ball and socket joint, which is the shoulder or the hip. We've got adduction. So adduction is the opposite of abduction. Adduction is bringing the limb back to the center line. So again, you might imagine a hook in boxing where the arm comes round and ends up back towards the middle. Even catching a ball in rugby, so you catch a ball and bring it into the centre line to protect the ball as you're running with it, would be adduction, bringing it back towards the centre line of the body. And the final one we're looking for is circumduction, and this is where one end of the limb stays still and the other makes a circular motion. And as we discussed in class, there's not lots of examples of circumduction, to be honest. I've never really seen many questions on it in exams, but we have to know it's there. So circumduction, one end of the limb stays still, the other makes a circular motion. We had the example of in rhythmic gymnastics where you're doing an arm turn to make the ribbon make a spiral. We did have a couple of other examples of from water polo or swimming when you're treading water. There's not lots of examples, but we do need to know it's there as well. So our 6 movements at joints are flexion, extension, abduction, adduction, rotation, and circumduction. Okay, and again, make sure you can give sporting examples of each one or recognize where you're seeing it in a picture. And if you do get a picture in a test, make sure you look at what's happening in the picture at that point. Don't make a presumption of what happens next. Final thing just to say is the 2 main joints, the hinge joint and the ball and socket. The hinge can only do flexion, extension, and the ball and socket can do all 6 movements. So flexion, extension, abduction, adduction, and rotation and circumduction. You can do all 6 movements at the ball and socket joint. Okay, and they will only be the only real joints they ask you about. So knee and elbow for hinge, and hip and shoulder for ball and socket. Okay, hope this has been some help to you. Again, obviously you can come and ask us if you need any help. Use your revision guides. There's loads of stuff online, GCSE Bite Size and GCSE Pod and things like that. Sometimes we've got the Everlearner on the go as well at school. But please use these podcasts to help you revise, as well as the other methods. Thanks a lot.